Chat room. Hello. Long time no see. Apologies for the lack of uploads. I've been really busy with school. And speaking of which, this video that you're watching right now, yes, right now, is actually a project for one of my classes. It's called Insects in the Environment. Don't worry. I'm working on another video, so hopefully that'll be out during my winter break. So, if you were here because you thought this was a Strive video or some other game-related video, I apologize, and you can click off. But if you want to learn something, then you can stick around. I don't mind that. Now, without any further ado, let's talk about nuclear energy. So, I asked you, yes you, the viewer, to fill out a survey on what you know about nuclear energy. And using the trends and patterns in your answers, I've put together a small PSA about nuclear power to hopefully teach you something new and destigmatize this nuclear option. Starting from the top, I asked you to tell me what you know about nuclear energy. It could be anything, right or wrong, it doesn't matter. I just want to know what you knew. And I was actually pretty surprised. A lot of you actually understood the general idea of how nuclear power works, and that they were generally a form of clean energy. So here's a short summary for those who don't know. There exists magic rocks that can boil water, and boiling water gives us steam, which spins a large wheel. I know, complicated, right? Going a little deeper, we need to shrink down to understand what an atom is. An atom is made up of three particles, a proton, neutron, and electron, and contains a core which holds neutrons and electrons. What we need to know is that that bond that holds that core together has a lot of energy. So when that bond is broken, it produces a lot of energy as well. But how do we split these atoms? We do that through a process known as... For this, we specifically use uranium atoms, which when collided with an external neutron causes the uranium atoms to split, creating that... Now, the reason we use uranium specifically is that when a uranium atom is split, more neutrons are released. And those new neutrons are then able to collide with other uranium atoms, creating more and more energy. This is known as a chain reaction and is the basis for nuclear fission. And now this is a model of how we harness that power into usable energy. This right here is the core, and it's made up of hundreds and hundreds of rods filled with uranium. These are also known as fuel rods, not to be confused with control rods, which are other rods that are made up of neutron-absorbing materials such as cadmium, hafnium, and boron. Like mentioned before, the chain reaction of colliding neutrons with uranium atoms is the basis for nuclear fission. But what if something goes wrong, and you need to stop it? That's where these control rods come into play. Once inserted, these control rods absorb all the newly produced neutrons, putting the reaction to a stop. These are the safety measures put in place to ensure that we can control these reactions. But anyway, back to fuel rods. They're bundled together to construct the core that you see right here. Then water is continually pumped in order to be heated, and this heated water is able to produce steam, which is then funneled into a large turbine, spinning it, generating electricity to be used. Now that we're all experts with nuclear reactors, let's discuss some of your concerns. Chernobyl. Cancer. Chernobyl. Yep. That'll do it. The largest pattern that I've noticed was fear of another Chernobyl disaster happening. One of the main reasons for the reactor's failure was that it was cheap. The RMBK was a Generation 2 light water reactor built with a graphite core. I won't really get into the specifics between light versus heavy water, but the main takeaway is that the design of the RMBK was to generate as much power as pretty much a heavy water reactor at only a quarter the cost and maintenance. This shortcut is what led to the disaster. In a quick summary, as the RMBK generated steam, a little pocket/bubble would form at its core. This was a void that didn't absorb neutrons. The existence of this void altered the balance of neutron production, which normally isn't necessarily a bad thing. It doesn't mean it's unsafe, as long as the people working the reactor know how to work the peculiarities of the system. Hint, they weren't. This combination of flaws is what really led to the disaster, and since then, all RMBK reactors were heavily reworked and went through significant changes, and in the United States, they were completely retired. We were able to learn from the disaster that occurred in Chernobyl. In the United States at least, that reactor was completely retired, and now we have significantly more regulations and standards for how the workers need to be educated. Not to discredit Chernobyl as well as other disasters such as 3 Mile Island as well as Fukushima, but it's been pointed out that in over 17,000 cumulative reactor years of commercial nuclear power in over 33 different countries, there have only been 3 major incidents, being Chernobyl, Fukushima, and 3 Mile Island, each of which we've grown and improved from. The other largest concern I saw was cancer. Does working at a nuclear plant as well as living near one increase the risk of cancer? In a study that encompassed over 480,000 workers and over 7.5 million residents, it was found that among workers that regularly worked and were exposed to small doses of radiation, there was actually a lower risk of cancer, but at the trade-off of an increased risk of mesothelioma. But most people aren't going to be working in nuclear power plants. This study found that residents within a 30-kilometer radius, or around 18.5-ish miles of a nuclear power plant, were at an increased risk of all cancers by around 5%. Thyroid cancer 17%, and leukemia 9% compared to those living outside that 30-kilometer zone. While these numbers are definitely daunting, I was recommended by 2 survey participants to research the link between the use of coals and fossil fuels and elevated cancer risks. For those exposed to particulate matter from air pollution, there was found to be an 8% increase to breast cancer for women, 10% increased incidences of brain cancers among the general population, links to ovarian cancer, potential but non-conclusive links to childhood leukemia, and many more. All of this linked back to air pollution and the use of burning coals and fossil fuels. Another study I found also linked air pollution not just to an increased risk of getting cancer, but to the mortality rate as well. It was found that for cancers in the upper digestive tract, there was a 42% increased mortality rate, 35% for liver, bile ducts, gallbladder, and pancreas cancers, 36% for lung cancers, and a whopping 80% increased mortality rate for breast cancer. As one of the survey participants pointed out, cancer caused by coal has killed significantly more people than any nuclear incident ever. While I don't want to justify increased cancer risks as a proper trade-off to sustainable energy, we have to take into consideration what's going on right now. As air pollution continues to get worse and worse, our risks of cancer actually increases far beyond that of the risks seen with nuclear power. And a final comment I want to make on this is that these increased risks to cancers, these zones, are generally isolated to an 18.5-mile radius around these nuclear plants, whereas air pollution affects all of us everywhere. To close out the video, I just want to address a few small I would like to address a few small points and concerns that were brought up that weren't of the 2 major concerns. So I'm gonna try to do this like rapid, just like boom, 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 boom. Don't worry, unrelated to nuclear power, but we have mutually assured destruction, so we're safe enough, I hope, maybe. We keep these really far underground in steel containers. We're chilling. Awesome! Good. Down with big oil. Me neither. We use uranium. There's a... Sorry, Professor Hawkins. Shit ton of uranium. We are not running out of uranium. Don't worry about that. No. Anyway, I hope you learned something. I hope you get an A. And thank you for the 40+ participants that actually took my survey. I actually appreciate it a lot. Thank you so much.